Now we want to find equations in Cartesian coordinates for curves that are given by their polar equations. So let's start with the curve of polar equation r equal 2. So in the xy plane, if we look at the point of polar coordinates r equal 2 and theta equals 0, it's right here. It makes an angle 0 with the positive x-axis. And you see that for the points on the curve r equal 2, there is no condition on theta. So theta could be anything. So if I start changing theta, if theta increases from 0 to 2 pi, and I track what happens to this point as r stays equal to 2 and theta increases, this is what happens. The point describes a circle centered at the origin and of radius 2. And we know that the Cartesian equation for this circle is going to be x squared plus y squared equal 2 squared, where the radius is 2. Or specifically, because if r is 2, then r squared is 4. And r squared, as we know, is the square of the distance to the origin, so it is x squared plus y squared. Turning to the second equation, theta equal constant instead of r equal constant. Here we're looking at the curve of polar equation theta equals 3 pi over 4. So that means that the points on this curve, to draw one, I would have to look in the direction 3 pi over 4. And then look at the constraint on r. Here we have no constraint on r. R could be anything. So if I start with r equals 0 and increase r, I'm moving away from the pole along this line. But r could also be negative, and we could have the other half ray. In other words, theta equals 3 pi over 4 is a line through the origin that is determined by this angle 3 pi over 4 that the line makes with the positive x-axis. Now what is its Cartesian equation? We know that tangent of the angle theta is y over x, at least for x non-zero, and that means y is tangent 3 pi over 4 multiplied by x. And tangent 3 pi over 4 is negative 1, so we get the equation of line y equal negative x. This is the slope, the line through the origin of slope negative 1. The condition x non-zero here is not important, because if x equals 0 in that equation of line, y is also 0. In other words, that corresponds to the pole. And the pole is a point that is on the curve theta equals 3 pi over 4, because we can pick any angle for r equals 0 and get the pole. Now let's look at the curve where r and theta, a curve that depends on both r and theta, unlike the previous two examples. And here r is equal to 3 sine theta, and we want to find the Cartesian equation. So one way to do that is to observe that y is equal to r sine theta, and on the other end, along our curve sine theta, we can replace sine theta by y over r in our equation, and that way we get that r is equal to 3 multiplied by y over r, and multiplying both sides by r we get that r squared is equal to 3y. Now this is a more convenient way to write it for us, because now r squared is easily expressed in terms of x and y. It is x squared plus y squared, the square of the distance to the origin. So we obtain the Cartesian equation x squared plus y squared equals 3y. And we could leave it that way because this is a Cartesian equation of the curve. Now you may or may not recognize this equation as an equation of circle. Maybe it is more explicit if we subtract 3y on both sides to have everything on one side, and then complete the square in the expression y squared minus 3y. So we replace y squared minus 3y by y minus 3 half squared minus 9/4. In other words, minus the square of 3 half. And putting this 9/4 on the other side, what we obtain is x squared plus the square of y minus 3 half equals 3 half squared. In other words, this is a Cartesian equation of the circle centered at the point of coordinates 0, 3 half and of radius 3 half. So So this is a circle, and you see that this is a circle that is centered on the y-axis and tangent to the x-axis. And you can easily convince yourself that redoing the same calculation where r is equal to a constant multiple of sine, you're going to find a circle that is centered on the y-axis and tangent to the x-axis. As you can expect, in the case r equal a constant multiple of cosine, we're going to do a similar calculation and again find a circle. Indeed, we can write cosine of theta as x over r and replace in our equation. So we get r equal x over r, multiplying both sides by r, we get r squared is x, and r squared is x squared plus y squared. So we get x squared plus y squared equal x. Again, at this point we already have a Cartesian equation of this curve, but to obtain explicitly the center and radius of the circle, we can subtract x on both sides and complete the square in x squared minus x. X squared minus x can be rewritten as x minus 1/2 squared minus 1/4. And putting the 1/4 on the other side, what we obtain is x minus 1/2 squared plus y squared equal 1/2 squared. In other words, this is the Cartesian equation of the circle centered at the point of coordinates 1/2, 0 and of radius 1/2. So it looks like that. It is centered on the x-axis and tangent to the y-axis. And of course, if r was another constant multiple of cosine, we would do a similar calculation and obtain again a circle centered on the x-axis tangent to the y-axis. Now let's turn to regions of the plane that are determined by inequalities involving the polar coordinates. Starting with the region determined by the inequality r is between 2 and 4. Well, we know that r equal 2 is a circle centered at the origin of radius 2, and r equal 4, the circle centered at the origin of radius 4. So if r is between 2 and 4, that means we are in this annulus between these two circles. What about an inequality on theta? If theta is between 0 and pi over 3, we know that theta equals 0 corresponds to pointing in the direction of the positive x-axis. Theta equal pi over 3 corresponds to pointing in this direction that makes an angle pi over 3 with a positive x-axis. And here we have no constraint on r, and theta is anywhere between 0 and pi over 3. So we obtain the angular sector between these two half rays. And if r is positive, we have any distance to the origin, but we need to stay in this angular sector. If we allow r to also be negative, then that means that we're going to get this other side of the cone, and this is the region that we obtain that is determined by the inequality theta between 0 and pi over 3 with no constraint on r. What if we add a constraint on r? For instance, that the absolute value of r is greater than 2. Absolute value of r equal 2 corresponds to the circle of radius 2. And if we ask the distance to the origin to be greater or equal to 2, then we're going to cut out what's inside the disk, cutting that out of our angular sector theta between 0 and pi over 3. Of course, if r is greater or equal to 2, that corresponds to this part of the angular sector that is in the first quadrant, whereas in the third quadrant that corresponds to r less than or equal to negative 2, because this part of the region theta between 0 and pi over 3 in the third quadrant corresponds to r negative, as we have seen. So for instance, if instead of absolute value of r we had just r greater or equal to 2, then we would just get the first quadrant part of this region. Now finally, we're looking at the region of the plane determined by the inequality r is between 0 and 3 sine of theta. So r greater or equal to 0, we know what that is. R really represents a distance and not sine distance to the origin. On the other hand, we know what the curve r equals 3 sine theta is. We've seen that before. This is the circle centered at the point of coordinates 3/2, 0 and of radius 3/2. And if I look at a point on the curve r equals 3 sine theta corresponding to the angle theta, this is exactly the point corresponding to r equals 3 sine theta for that particular value of the angle theta. And so for that point of polar coordinates r theta, r is equal to 3 sine theta. R is greater than 3 sine theta if we are on the red part of this half ray. I'm sorry, the green part of this half ray, as you can see. Then we are further away from the origin than 3 sine theta. So this is this green part. And r less than 3 sine theta correspond to this, this purple part of the half ray. Now if we let theta range from 0 to 2 pi, what we obtain is a disk. So this inequality corresponds to the disk centered at the point of coordinate 0, 3/2 and of radius 3/2. Let's on to the next video to see more about polar curve.